Let me take you through a quick demo to show you how quickly and easily we can use IBM Fusion HCI to deploy an AI server for large language model chat application. So we start with an OpenShift cluster. This is actually Fusion HCI deployed in our Poughkeepsie lab that we can utilize for different data service from HCI. So here I can go to the Fusion HCI tab to look at all the data service that's being deployed. And some of these data services will not be using in the demo, but data foundation is going to be very important, as well as the infrastructure. For example, here we have 9 nodes, 9 servers, physical servers. One of them is a GPU node, RU25, that we're going to be using it for the GPU resource. So if I click into the GPU tab and I go to the back view of the server, I can see 1, 2, 3. There's 3 A100 GPU that we'll be using for the POX setup. We can also go to the network tab, look at the network, and of course there's other service that will not be showing, like backup restore, a very commonly used data service for providing resiliency for hybrid cloud. Now I've shown you the HCI side. We'll come to the OpenShift side and look at the pre-installed virtualization tab. Here we can look at the number of resources being provisioned. So there are 10 virtual machines already being created, pre-created, and they are ready to be used. And they are consuming this total resource, although most of them came from 2 virtual machines, shown here on the bottom of the list, these 2. They're actually 2 Windows server with GPU attached to them, running a pretty much a critical POX for a client with a MATLAB workloads. The other servers are all stopped, so they're not consuming resource, but ready to go. So what I'm going to do next is I'm going to take one of these virtual machines, activate it with GPUs, and making sure it has all the necessary data service, and then make it ready for the pilot, the remote pilot. So we're going to click into this virtual machine called Rail 9 Frank, which is deployed with Red Hat Enterprise Linux with preset configuration of memory, CPU, although we can customize it under the configuration tab by changing the CPU or the memory. We're also going to look at the scheduling policy here. You can see that when the virtual machine starts, it's going to pick a GPU node, which in our case is RU25. We're going to come to the detail tab and click on the GPU device. So here we can pre-select a GPU resource to match to this VM. So we're going to pick a A100 adapter from one of the RU25 from the node that has the A100 cards. Say save. And finally, we're going to look at the storage setup. So in this case, the this Rail Frank is using a PVC with the same name, maps to a Fusion Data Foundation storage class. This 120 gigabyte will be provisioned from Fusion as a volume for this particular virtual machine. So with all of this set up, we're going to come here and click Start. This will start the virtual machine image using the data service from Fusion, and then with the GPU pass-through from the host node, the RU25, and you can see the node is already coming up. It's already picked. It is picking RU25. Okay, you can see already from the console, the VM is already starting, so it's pretty quick. And you can even click to the console view and monitor the progress of the virtual machine. And even connecting to the virtual machine when it's fully started up here, directly in the console. Okay, so we're gonna come back here and also monitor that's the other status. For example, we can go to the virtual machine tab and see that the server is already running, and it's on the RU25 node, and it's waiting for an IP address to be assigned, because the IP address will be matched to the network configuration, which I'll show you now. So if I go under the network, so I create a network interface matching to the network cards on the VMs using a bridge type, which allow us to create an IP address mapping to this MAC address. So now let's come back here and see the address was already assigned. So with that address, I can do a couple of things. One of which is access the server directly. So in this case, I'm gonna click on the our SSH terminal, and we can see the server is already up and running. So we type uptime. You can see it's up for 1 minute. And we can even look at the NVIDIA card. We can see we have a NVIDIA card set up, A100 available, and with no workloads running for now. So what we're going to do here is we're going to actually use this IP address with a domain name mapped to it and try out the AI application that's already deployed. So we're going to go to the URL for this application. Okay, so we now landed on the application. It's a chatbot based on Ollama and with some modification. So one of the modification I built is the ability to manage model. For example, we can list all the available model from Ollama. There's a total of 293, including some of the latest, like the IBM Granite 3.2. And we can download the model from here quickly, and even delete model that's already being loaded. So with this, I can come here and pick a model I want to use, right? So in this case, I'll pick a small model, the latest IBM Granite 3.2, which is released last week, 2 billion parameter, and ask the question, can you tell me the value of IBM Watson X for AI journey? Right. So what happened is this query will be processed by the Granite model running locally on the VM, which is hosted in Fusion HCI using the GPU resource locally as well. So everything's local, running on this AI virtual machine. If I come to the backend, I can run this command again. You can see this application I just run is a process ID, and it's actually using the memory, which is about 3 GB memory, although we have a total of 40 gig, so this should be sufficient. 40 gig here, 40 gig here. Okay, so this concludes the demo to show you with Fusion HCI and its data service, and also the infrastructure resource like servers and GPUs, we can quickly spin up and run a AI virtual machine and deploy an application quickly. This concludes the demo. Thank you.